Okay, so last time we went through 2.3. We finished that up completely. And 2.4. So what questions do we have out of 2.3? And I think 2.3 is probably the most difficult section. So which ones would we like to look at out of 2.3? Sure, 17. I'll add on 12 because I know that was one of the most difficult ones with the fractions. We can look at that one.
Did we do 6?
Yep, we went through them all, so we can go ahead and look at question 6. Sure, question 18. Okay, any others to look at?
Like 8, 9, or 10. One of those.
Yeah, we can do one of those. How about we do 8 and 9, because those are two different ones. So we'll look at 8 and 9. Okay, do we have any others to add to the list? So we've got 6, 8, 9, 12, 17, and 18 out of 2.3. What about out of 2.4? Now, those are the ones that required us to shade. So which ones out of 2.4 would you like for me to work through?
Either 7 or 8.
Sure, yep, we can look at 7 and 8 both just to make sure we know how those work.
9.
Sure, question 9 also.
6.
Yep, 6 also. Okay. Is that going to take care of all of those then? Do we need to add any more?
Maybe 4.
Yep, we can add 4 also. Okay, anything else? All right, well, we can go ahead and start with these, and we can add more to the list if we need to. So let's now begin with 2.3. And 2.3, some of these are really difficult because of all the algebra that's involved. They're kind of time consuming. In 2.3, we don't have to graph them. We just have to make sure that we get our answer in the correct form. So we'll go ahead and look at question number 6 out of 2.3 first here. Now this one's talking about a parallel line. And what do we know about parallel line? Well, what's the same as far as the slope? Okay, if we're looking at parallel, what does that mean? That means they have the same slope. So we need to take this equation and we need to solve it for y to get the slope. So let's just kind of talk about what we're going to do on this one. First things first, we're going to take this equation and we're going to solve it for y. That's going to give us our slope. Now, we do not have to change that slope because it's parallel. So whatever slope we find, we use that slope along with that provided point to get our line equation. And for question 6, we want it in slope-intercept form. So again, that means that we solve it for y at the end. So we're going to take our equation and we're going to go ahead and solve that for y. So I'm going to add that 7x over. And that leaves us then with 5y equals 7x plus 57. And we're going to divide everything by the 5 there. And now we have it in what's called slope-intercept form. So that's our first step, is we take that provided equation and we solve it for y. Now, once we've solved it for y, we need to find the slope. And how do we find the slope once it's been solved for y? Well, once this equation has been solved for y, the number in front of my x is the slope. So in this case, my slope is going to be 7/5. Now, do we have to change that slope at all? No. It's parallel. If it would have been perpendicular, then what would we use? We would use the negative reciprocal or the opposite reciprocal. So if this would have been perpendicular, then we would use a minus 5/7. This is parallel, so we're going to keep that slope the same. Now we're going to use point slope. And what do we have for the point slope? Well, we have a slope of 7/5. We use our original point that's provided, which is a minus 6, 5. So we're going to use that 7/5 with that provided point of minus 6, 5. And what's our point slope formula? Well, it is y minus y1 equals m times x minus x1. Now, to use this formula, we need a point and a slope, and we already have that. To use our point, we label it x1 and y1. And now we plug our values in. I always like to write the formula down every time I use it. That way I have it there to look at. We plug our numbers in. Watch out for double negatives. And that is then y minus 5 equals 7/5 times x minus a minus 6. So you've got to be careful about the double negatives there. That's where students make a mistake, is right here. So this double negative right here, that makes that positive. And then we'll go ahead and distribute through. So now we are left with y minus 5 equals 7/5 x. Now, what about this 6? Well, this 6 is like a 6 over 1. So multiply our numerators. So 7 times that 6 there, that makes it a 42 over 5. So that's what we did there. We just multiplied through. Now, we want to go ahead and get this in slope-intercept form. And the easiest way to do that is to go ahead and clear the fractions. So to clear the fractions, we've got a 5 in the denominator. So we multiply everything by a 5. And this is another place where students make a mistake. Everything has to be multiplied by 5. So that gives you 5y. We distribute through. 5 times a negative 5, that makes it a minus 25. That equals then 7x, because those cancel, plus 42. Now we want this in slope-intercept form, and we're almost there. So we need to add that 25 over. And that leaves me then with 5y equals 7x. And then we've got 42 and 25. And that makes it a 67. Last step is going to be divide all the components by 5. And now we've got y equals 7/5 x plus 67 over 5. And that's going to be our final answer. And that is in the form that we want, which is the slope-intercept form. So we solved it for y, moved everything around. We got our slope. We took that slope, since it's parallel, we kept it the same. We used our point slope formula. We used that point slope formula, distributed through, cleared the fractions, and we got our final answer in slope-intercept form, which is what we wanted. And I know these can be difficult just because of all the algebra. So that was question 6. Question 8. Question 8 is perpendicular. So we've got -5, -2. We want this to be perpendicular to -5x minus 2y equals 27. So we're going to repeat the process that we did on the last one. Now, what's going to be the difference? The difference is it's perpendicular. So when we find our slope, what do we have to do? Flip it over, change the sign, right? Then proceed to use the point slope formula. So follow that step-by-step flow chart that we have here. So first things first, we're going to take our equation and we're going to solve it for y. So add that 5x over. Now we have a -2y equals 5x plus 27. Divide by your -2. Be very careful with your signs here. That then leaves us with y equals -5/2 x minus 27 over 2. And that again is our slope. And so that's a -5/2. Now that is not the slope that we're going to use though, because we want it to be perpendicular. So what are we going to have to use for our slope? We use for the slope negative and negative makes it positive because you switch your sign out. You flip the fraction over. So we're going to use 2/5. So positive 2/5 is what we're going to do. We're going to flip that fraction over and switch the signs. Now we can use that slope with that point in our point slope formula. So we're going to use that m equals now 2/5 because that's the slope we're going to be using. We've got a -5 -2 for the point. So x1 again, y1. And our point slope formula is y minus y1 equals m times x minus x1. And again, we're still in question 8 here. So we haven't finished up 8 yet. But here's our formula. We've got everything that we need. We've got our point. We've got that perpendicular slope, negative reciprocal or opposite reciprocal. Plug in our values. Watch out for those double negatives though. So we've got y minus a minus 2 equals 2/5 times x minus a minus 5. So we're going to go ahead and get rid of the double negatives. That's going to make those positive. And then we'll distribute that 2/5 through. So let's go ahead and do that. Now the fraction on that 5, and we distribute it through with that 2/5, it's going to go away. So to save us from clearing the fractions, we're going to distribute through. So that's y plus 2 on the left-hand side. And then we've got 2/5 x. Let's go ahead and distribute through here and see what we get. So we've got 2/5 times that 5 over 1. You can either cross cancel here or just multiply across and reduce. So that's 10 over 5, and that reduces down to a 2. Just to make it easier, that way we've got one less fraction to work with. Now again, we want this one in slope-intercept form. So there's really not much else to do besides move that 2 over. And now we've got it. We don't have to clear the fractions because we want this in slope-intercept form. So that's 2/5 x, because the 2's cancel each other out. So our answer then would simply be y equals now 2/5 x. So now we finished 8. 9 is a little bit different. Okay, 9 is a much easier problem as long as we understand what to do. 9 does not require much algebra at all. Now, what do we notice about this one at the beginning? Well, we only have one variable, and it's an x equals 5. So if we start with one variable, at the end, we're going to end with one variable. Okay. You've got both x and y at the beginning. You'll get your equation. In this case, though, it's a much easier problem. What do we know about x and y? Well, x is perpendicular to y. Very important fact there. Okay, x is parallel to x, y is parallel to y, and x and y are perpendicular. They make lines like this. They make an x like this. So in this case, what is our answer going to be? We want to be perpendicular to that x line, so it's going to be a y line. And what's our y component of this ordered pair? The y component of this ordered pair is simply what? Is simply 9. So what would our answer then be? Y equals 9. And that is one of the questions that's most commonly missed on an exam. Students struggle with this because it's so easy, and you think there's more to do, but there's really not. So just remember, anytime you have one variable at the beginning, you end up with an equation that has one variable. Two variables gives you two variables. One gives you one. So that is question 9. Now, question 12 we didn't ask about, but I'm going to go ahead and go through it with you so you see how to work with these fractions and how to get rid of them, and then how to reduce our answer to the correct form. So question 12, we want it in standard form. And we've got 3/4, comma, 5/4 for a first ordered pair. Our second ordered pair is 1/3, comma, 2/3. Okay, so think about what we've got. Do we have an equation to begin with? No. Do we have a slope to begin with? No. Now, we eventually want to use the point-slope formula. So we're going to have a slope. Now, how do we get that slope? Well, we can either get that slope from an equation, which we do not have, or we can get that slope from 2 points, which is what we have. So we're going to use our slope formula. And our slope formula is m equals y1 minus y2 over x1 minus x2. So the y's are in the numerator, x is in the denominator. So x1, y1, x2, y2. So let's go ahead now and plug in our values. And we've got, for our y's, we've got 5/4 minus 2/3 over 3/4 minus 1/3. How do we handle these fractions? Well, we could work with them, but students always struggle with the fractions. So look at all the fractions. Now, we can get rid of them all by multiplying everything by what? Does anyone know what I can multiply everything by at the very beginning to get rid of all of those fractions? 12, okay? So I'm going to multiply every component by 12. That is going to clear out all of the fractions. So everything in the numerator and the denominator gets multiplied by 12. Now that doesn't change things because 12 over 12 is just a factor of 1, so it doesn't change it at all. What that does do is get rid of our fractions. So let's now go ahead, clear out our fractions, and reduce down our slope. So go ahead now and clear out our fractions. Well, 12 divided by 4. 12 divided by 4 is a 3. 3 times that 5 makes it now 15. So there's that piece. 12 divided by 3 is 4. 4 times a negative 2 makes it a negative 8. 12 divided by 4 is 3. 3 times 3 makes it 9 down below. 12 divided by 3 is a 4, times a negative 1 makes it a negative 4. Now we can easily calculate our slope. So we've got 15 minus 8, that should be a 7, in the numerator. And we've got 9 minus 4, that's a 5. So now we've reduced that down, and we have our slope. What do we do next? Well, next we use point slope. And this one is a little bit trickier because of the fractions. So we've got our slope, which is 7/5. And we'll just use our first ordered pair. Does not matter which one you use. We'll just use our first one, which is 3/4, comma, 5/4. x1, y1. And again, just so you know, we're still in question 12 here. Write up our formula so we have it, which is y minus y1 equals m times x minus x1. We fill it in. So that's going to be y minus 5/4 equals 7/5 times x minus 3/4. Distribute through. Okay, so now we've got y minus 5/4 equals, we've got 7/5 x. How do we handle multiplying fractions? Well, what do? We multiply the numerators, multiply the denominators. So 7 times that -3, that makes that a -21. 5 times that 4 makes it a 20. We need to clear out our fractions. And so we're going to multiply everything by what? Does anyone know? 20. That's going to clear out all of our fractions quickly and easily here. Now we've got 20y. 20 divided by 4 is a 5 times a -5. That makes it a minus 25. 20 divided by 5, that's a 4. 4 times that 7 makes it a 28x there. The 20s directly cancel, and that leaves you with a minus 21. This one is different from the last ones for our answer, because on the others, we wanted our answer in slope-intercept form. But we want this one in standard form. So we're going to go ahead and add that 25 over. And then we'll move that 28x over with subtraction. That leaves us then with a minus 28x plus 20y on the left. On the right, we've got a minus 21 plus 25. That makes it a 4. Not quite in standard form yet because of that negative in front. So how do we get rid of it? Well, we can divide or multiply by a negative. So let's go ahead and do that. It's going to make that then 28x minus 20y equals a -4. I would accept this as an answer, but to get the same answer that the textbook has, we need to look at all the numbers. Okay, so to get this reduced down as far as possible, let's look at all the numbers. We've got a 28, we've got a 20, and we've got a 4. So what number goes into 28, 20, and 4? What's the largest number possible? These all have factors of what involved? Factors of 4, right? Because 4 goes into 28 7 times. 4 goes into 20 5 times. 4 goes into itself 1 time. So let's divide everything by a 4 to finish it out. This way we get the same answer as our textbook does. And so 28 divided by 7, 28 divided by 4 is a 7 there. So that's what we want there. Negative 20 divided by 4, that gives you a 5y. And negative 4 divided by positive 4, that reduces down to a -1. That's what we've got for our final finished answer. So this one would be okay up here, but to make it match up with our textbook, we need to reduce it down. So everything was divisible by 4. And the only time you have to do this is when you have a question that has you clear the fractions. You have to clear the fractions. Always make sure that you can't reduce it down any further. And that was the most difficult problem in this section. You're not going to have anything quite that difficult on your exam. So on your exam, you might have something like question 8. That's an easy one. You'll probably have that one. You'll probably have something like question 9 also, because that's just an X one, where you get the Y value for your answer. We've got a couple more, 17 and 18. So 17, we need to make sure we know how to get this one in slope-intercept form. So we want slope-intercept form. And what does slope-intercept form look like? Well, slope-intercept form is y equals mx plus b. Okay, so that's where we want our answer to be. We want it to look like that. So to get it to look like that, slope-intercept form, what do? Well, we move everything around so that the y is on the left, x is on the right. So move that 3x over with subtraction. That gives you then a minus 10y equals a minus 3x minus 6. We'll divide by our negative 10 and reduce it down to b. Y equals now, negatives cancel. So that's positive 3/10 x there. The negatives cancel, and 6/10 reduces down to 3/5. So there's your final reduced answer. So make sure that you reduce that 6/10 down. So when you get an answer, you've got to make sure that you cannot reduce those fractions. So is everyone okay with what we did there? So just solved it for y. Now, slope-intercept form, what is that? That has been solved for y. So it's got to be y equals, which we did. We moved it around. We reduced it down. And that's our final answer on 17. 18, we could use the point slope formula, or we can just realize that is a y-intercept. Either way. I think last time we went over this one in class last week, I'm pretty sure, but this time we'll just use the point slope form. So we'll use the point slope form. You could do it either noticing it's an intercept or just working with the ordered pairs. So we could use the fact that this is an intercept, the y-intercept, and we could jump directly to our answer. But let's say we didn't realize or remember that this is a y-intercept. Why is it a y-intercept? Because your x value is 0, right? We could jump to our answer, but let's say we're on an exam, and let's say we forgot that. And we forgot that fact, so let's go ahead and use this point with our point slope formula. And again, you could just jump directly to your answer, because we want this in slope-intercept form. We could have jumped directly to our answer. But let's say we didn't realize that that was an intercept. That was your y-intercept there. So let's pretend like we don't know that. And that's m. Sorry about that. Skipping a step here. And that's x minus x1. And we'll plug our values in. This is your x and this is your y here. X1, y1. So plugging them in, we get y minus a minus 4 equals 1 times x minus 0. The double negative makes that again positive. When I distribute that 1 through, that 0 doesn't matter, so it's going to be gone. So on the right-hand side, I am left then simply with an x. The left-hand side, we have y plus 4. Move that 4 over, and we're done. Which is y equals now x minus 4. And just so we know, our slope would be 1, because there's no number in front of the x. And your y-intercept is 0, negative 4. Now, you could have gotten this simply by looking at it and realizing that this right here is a y-intercept. And I could have skipped all this work and jumped directly to our answer, right? We could have done that. But let's say we're on an exam, and we forgot that this is a y-intercept. Can we still use point slope? Yes, it will work. It'll give you the exact same answer. So then just plug your values in. That 0 actually just goes away, and that gives you the same answer. So you could either realize that this is a y-intercept and jump directly to your answer, or if you didn't see that, if you were on an exam, then you could just work it out and get the same result. And we've got a few questions out of 2-4. These are much easier. The questions out of 2-4 are going to be a lot quicker to work through, as long as we can remember the concepts. Now, what do we know? Well, we're going to be graphing these lines greater than or equal to, less than or equal to. Those get a solid line. Strictly less than, strictly greater than, those are going to get a dotted line, right? So remember, it's either solid or it's a dotted line. We'll do 6, and then I forgot about 4. So we'll do 6 and then come back and get 4. Now, 6 is x is greater than or equal to 1. Let's take a moment to remember what an x line looks like. Now remember, on these, if you get one variable, it's either a vertical line or a horizontal line. So up and down or left and right. What about this one? X is greater than 1. Do you think that's a vertical line or a horizontal line? Okay, which one? Does anyone remember? Vertical or horizontal? It's going to be vertical, right? How do we know that? Well, x is 1. This is your x-axis, so we find our 1 here. Solid or dotted line, do you think? Solid line. So that's going to be a vertical line, just like that. Now, it's either going to be shaded to the left of the line or to the right of the line. How do we know which way? We pick a point. Just make sure that you pick a point that you can clearly see where it's at. Now, 0, 0, we can clearly see that it's on the left. So let's check that 0, 0 and see if it's true or false. We're going to check this in. X is greater than 1. So this is our x value. So is 0 greater than 1? Is that true or is that false? Is 0 bigger than 1? No, 0 is not. So that makes that false. The line divides the shading. So that means this half is false. The line divides it, so the other half is going to be what? True. Okay, where do we shade? We shade the true side. And the true side is right over here. And there is our answer. So it's a vertical line, and we're going to be shading to the right, because we checked it at 0, 0, which was left of the line. That was false. So that means the other side has to be true. So we shade the true half. Question 4. I forgot to get that one. So we'll go back and get that one. Okay, question 4 is x plus 3y is greater than or equal to 5. Now this one, it's got the x and the y both, so this is going to be a diagonal line. Anytime you've got both the x and the y, it's a diagonal line. So let's go ahead now and find our slope. How do we do that? We solve it for solve it for y here. Move that over, and now we've got 3y equals minus x plus 5. We'll divide everything by that 3. Now we have y equals minus 1/3 x plus 5/3. My m is minus 1/3, and my y-intercept is the ordered pair 0, 5/3 there. That's what we need. To graph a line, we need a point and a slope, and we've got that. That slope is our minus 1/3. That point is our y-intercept. That's the b component. So we're going to start up 5/3. Now, what is 5/3 as a decimal? Well, 6/3 would be what? 6/3 would be 2. So 5/3 is a little bit over 1.5. It's close to 2. So that's going to be up about 2 units. So we'll put that 0, 5/3. We'll put that right there. And then what are we going to do? Our slope is minus 1/3. So that means we need to go down 1 and over 3. So we're going to go down about 1 unit. And then we're going to go over 1, 2, 3 units. So down 1, over 3. Make your new dot. Connect them together. We're going to use a solid line again. And we need to check a point that is not on that graph, on that line. Easy point to pick that's not on there in this case, you can tell where it's at, is 0, 0. You can pick any point that you want. Just make sure it's not on that graph, on that line. So it's not. So let's go ahead and check 0, 0. We're going to check it in. X plus 3y is greater than or equal to 5. So plug the zeros in. And is 0 bigger than 5? Nope. So that would make that then false. So that means this half is false. The upper half must be true then. And so where do we shade? The true part, which is the upper half. Pretty simple on that one. Solve it for y. Get it in your slope-intercept form. Check a point. Usually we pick 0, 0, but in some cases we can't do that. In this case we could. So we just checked that 0, 0, and we found it to be false, so we shade the other side. That line divides it between the true and the false half. So 3 more it looks like. Question 7. Very similar to question 4. So we're going to do question 7 here. And these are easy questions, and I want to make sure we don't miss these, because these are very simple to work with. So question 7 is x minus y is greater than or minus 2. So we need to solve it for y again. So I'm going to move that x over. And minus y equals minus x minus 2. Divide by a minus 1. Now we've got our slope-intercept form, which is y equals now. Negative and negative makes it a positive x plus 2. No number in front of the x, so it's understood that there's a 1 there. So that's why our slope is 1. And my y-intercept is 0 in this case, comma 2. Because that number on the end is the y component of your y-intercept. Now we'll graph it. We'll start at 2. Up, so that's 0, 2. My slope is 1 over 1. So up 1 and over 1. So this is where we start. We go up 1 and we go over 1. Make our new dot. And we're going to go ahead now and use a dotted line. Why? Because it is strictly greater than. So there's our dotted line there. There's our point. We went up 1 and over 1. Made a new dot right there. Now we're going to check. Easy, easy point to check is 0, 0. Okay, now notice we got this 2 on the end, right? So that means we're going to start up 2 units. So we started at 0, 2 right here. And then from that 0, 2, we used our slope. So from that 0, 2, what do we need? Slope is 1, so that's 1 over 1. So at that 0, 2, which is right here, where the tip of the pen is, what did we do? Up 1, okay, and then over 1 to the right. And that made my second dot. Why are we using a dotted line? Right, because it's greater than, right? Anytime it's greater than or less than, we use a dotted line. Greater than or equal to, less than or equal to, those get the solid ones. Now, we know 0, 0 is here, so it's below the line. So let's check that 0, 0 back in the original. And that is x minus y is greater than or negative 2. So plug our values in. And is 0 bigger than a negative 2? Is that true or is that false? Is 0 bigger than a negative 2? Yep, that would make it then true, wouldn't it? So what does that tell you now? That tells you then this half is true, this half is false. The line divides the 2 regions, and where do we shade? The true half, which is down below. We've got 2 more, and then we'll take a short break just to make sure we have these down. These are good type of test questions. We'll probably have our exam next week, I imagine, because we'll finish up 2.5 and 2.6 today. We should have enough time then to also look at the practice exam, because 2.5 and 2.6 are short, easy sections to work through. question 8. Okay, question 8 is almost exactly the same. Only difference is one of the signs. So very, very similar. The only difference is, instead of it being a negative, this one's a positive. So repeat the same process. Move your x over. And now we've got y equals a minus x minus 2. So my slope would be a negative 1. Because remember, it's understood that there's a 1 there. We don't write it. There's a 1 there. So that makes that slope a negative 1. And our y-intercept as an ordered pair would be 0, comma, in this case, negative 2. So it is a little bit different here. And we're going to start down 2 units. So that's where we start at, is 0, negative 2. My slope is a negative 1 over 1. So that means down and to the right. So we go down about 1 unit over 1 unit. That makes a new dot right there. Connect them together with a dotted line. And we still need to check. So we're going to check again that 0, 0. Always label it so you know where it's at. 0, 0 is clearly above that line. So let's check 0, 0. And that's 0 plus 0 is less than a minus 2. Well, is 0 smaller than a minus 2? Is that true or is that false? 0 larger than a minus 2? Or sorry, 0 smaller than a minus 2? No. 0 is not. It's larger. So that makes that then false. So then this half is false. This half is true. Where do we shade? Again, the true region. So we'll be shading down here. Okay. One more, and then we'll take a short break. Question 9. Already done for you for the most part. Now, question 9, we don't have to graph it because question 9 is already done. All we have to do is work out the shading. Now, you could solve it, you could graph it, and you could do all that work. But we really don't need to because it's already graphed for you. All we need to do on 9, and there's several of these, is just simply work with our shading. Yep. All we have to do is plug in that 0, 0 and see if it's true or false. So 0, 0 is right there down below. We can use 0, 0 because it's not on that line. And let's check that 0, 0. So plugging it in. That gives you 0 is smaller than 8. Well, is 0 smaller than 8? Yep, so that would make that then true. And so that means this half is true. This half is false. Where do we shade? The true side, so we'll be shading below. So hopefully you see how these work. And there'll be a couple of these on your exam. They're not difficult compared to 2-3. Questions out of 2-3 are definitely the most difficult. So let's go ahead and take a short break. And let's meet back here at 9:35. So let's meet back here at 9:35. And then we'll start 2-5.
So when you do the y-intercept, it's basically just whatever's on the other side.
Yeah, that once you've solved it for what? Okay, once you solved it for y, that number on the end, that becomes your y-intercept. And that's where you start on the vertical axis, because that's your b component. So if it was like y equals x minus 3, you would start down 3 units, and then use your slope from there.